Welcome to Physics Mint by Supreeth BS. The evolution of NEET Physics between 2020 and 2025 reveals a strong shift toward conceptual depth and logical reasoning. Across these years, the section has transitioned from straightforward numerical application to more integrated, idea-driven problem-solving. Each paper demonstrates the same consistent principle. Physics in NEET rewards understanding over memorization. The foundation of every paper remains built on the three major pillars of mechanics: electricity and magnetism, and modern physics. Within mechanics, the gradual refinement of questions highlights the need for conceptual clarity in motion, forces, energy, and rotational dynamics. Instead of isolated formula-based problems, the questions now blend kinematics with Newton's laws or combine rotational motion with energy conservation. The balance of logic and numerical application is delicate, requiring comfort with vector understanding and energy analysis. Thermal physics provides a steady portion of the overall paper, testing fundamental awareness of heat, work, and the laws of thermodynamics. Conceptual questions dominate here, especially those connecting the first law to cyclic and adiabatic processes. Candidates benefit from treating this topic as the link between mechanics and modern physics, where ideas of energy transformation continue to reappear in more advanced contexts. In the middle domain of waves and oscillations, NEET continues to emphasize periodic motion, resonance, and graphical interpretation. Instead of direct formula substitution, questions now favor visual logic, phase difference, amplitude relationships, and wave interference. Students with the ability to mentally visualize motion find this topic highly scoring. The portion on electrostatics and current electricity forms the analytical core of the paper. Year after year, these chapters demonstrate the importance of clear visualization of charge distribution, electric field interaction, and circuit logic. Even though the mathematical layer remains simple, the hidden test is reasoning under pressure, understanding how potential differences and equivalent resistances behave when combined. The interlinking of charge conservation and electric potential forms the true challenge. Magnetism naturally extends this discussion, merging theory with visualization. Right-hand rule-based reasoning, the motion of charged particles, and magnetic field interactions remain recurring themes. Questions often combine magnetism with current, forming multi-concept problems that require structured thought. Conceptual mastery of direction, field mapping, and Lorentz force continues to separate top scorers. Electromagnetic induction and alternating current occupy a transitional space between electricity and modern topics. Here, the trend clearly moves toward conceptual reasoning, changing flux, induced current, and phase difference between voltage and current. The NEET pattern in recent years often integrates graphical interpretation of alternating current cycles, encouraging understanding of RMS values and phase relationships. Optics continues to hold immense conceptual weight. Ray optics problems dominate with lens and mirror combinations that test precision in sign conventions and visualization of image formation. Over recent years, analytical comprehension of refraction and optical instruments has become more refined, rewarding those who think geometrically. Wave optics, although smaller in representation, still challenges understanding through interference and diffraction. Instead of memorizing conditions, clarity on path difference and coherence determines accuracy. Modern physics reflects the scientific evolution of the paper. Topics like the dual nature of matter, atomic models, and nuclear processes embody conceptual beauty rather than computational weight. The challenge lies in interpreting phenomena like photoelectric emission, energy quantization, and radioactive decay with logical consistency. This part of the paper strongly favors candidates who have visualized how quantum ideas translate into experimental reality. Semiconductors and electronic devices, though forming the closing segment of the syllabus, consistently offer reliable scoring opportunities. The focus is on circuit behavior, working of diodes and transistors, and logic gate fundamentals. The examiner increasingly favors diagram-based reasoning, where understanding the direction of current and voltage drop becomes essential. When observed collectively, the overall difficulty of NEET physics maintains a balanced gradient. Around half the questions remain moderate, requiring clear conceptual application but no heavy mathematics. The remaining ones distribute equally between easy conceptual checks and complex reasoning problems. The design philosophy of the paper has gradually aligned itself with testing conceptual fluency rather than algebraic memory. Mechanics remains conceptually broad and continues to set the tone for problem diversity. Electricity and magnetism dominate analytical engagement, while modern physics and optics provide predictable yet conceptual scoring areas. Thermodynamics and waves add balance by testing intuitive understanding of physical behavior. Together, these clusters ensure that every major domain of physics finds fair representation, forming a truly comprehensive assessment. The NEET physics trend also demonstrates the increasing role of diagrammatic reasoning. Graphs, vector diagrams, and circuit layouts now appear as tools for logical evaluation. A student who can interpret these visuals quickly saves valuable seconds during the test. Visualization is no longer optional, it defines problem-solving efficiency. The preparation insight drawn from these years is straightforward. NCERT remains the foundation, not only for theory, but also for question framing. Each illustration, example, and definition in the textbook aligns closely with the reasoning expected in the paper. Supplementary problem books and test series help reinforce application, but conceptual clarity must emerge from the textbook itself. Students who memorize formulas without understanding their derivations struggle to adapt when similar ideas are presented in new contexts. Steady practice with previous questions builds recognition of patterns in the examiner's thinking. Many questions are rephrased variations of classic concepts. The difference lies in interpretation speed. Therefore, regular timed practice enhances both accuracy and rhythm. Working daily on mixed problem sets, revisiting formula sheets, and visualizing physical processes create cumulative improvement rather than last-minute memorization. From an analytical standpoint, NEET physics between 2020 and 2025 represents stability with refined focus. The structure remains predictable, but the intellectual demand deepens. Conceptual integration between mechanics and electromagnetism, or optics and modern physics, is no longer rare. It is the norm. This evolution signals that physics has moved from being a scoring section for rote learners to a reasoning test for true understanding. The paper's ultimate message across these years is that physics rewards disciplined thinking. Success depends on internal logic, not on tricks or shortcuts. Every principle interconnects. Motion, energy, fields, and light are not isolated ideas, but parts of one continuous physical language. Students who develop this internal coherence perform consistently, regardless of shifts in pattern or difficulty. In conclusion, NEET physics from 2020 to 2025 continues to uphold the integrity of conceptual assessment. It stands as a subject that values comprehension, precision, and the beauty of logical reasoning. The continuity of this trend ensures that aspirants who study with understanding, practice with purpose, and think with clarity will always remain ahead. Subscribe to Physics Mint